Walk down any produce aisle today, and you will find pyramids of perfectly uniform, unblemished red supermarket tomatoes. We treat them as a reliable, structural pillar of the modern grocery store. Yet, biologically, the tomato is a delicate, fleshy fruit with a thin skin that bruises, squashes, and begins breaking down under the slightest physical pressure. That fragility created a massive crisis for California's agricultural industry in the mid-20th century. By the early 1960s, the Bracero program, which had supplied an abundance of migrant labor from Mexico, was coming to a close. Up until that point, the entire supply chain relied on thousands of human hands to gently pick and pack the delicate crop from the dirt. Without that immense labor force, millions of pounds of tomatoes were guaranteed to rot on the vine. To survive, growers had to trade the tomato's natural delicacy for a variety that could withstand the impact of a machine. In the early 1940s, a University of California Davis agronomist named Gordy Jack Hanna began a quiet, years-long quest to breed a tomato that could survive being harvested by a machine. Hanna eventually developed the VF-145, a firmer-skinned hybrid that earned the nickname the square tomato. Its slightly blockier shape solved a specific physics problem, preventing the fruit from rolling off the vibrating metal conveyor belts of harvesting equipment. With a durable fruit successfully engineered, Hanna teamed up with agricultural engineer Kobe Lorenzen in 1961 to launch a commercial mechanical tomato harvester. Hanna's breakthrough turned the tomato into a standardized component of an industrial system, where a plant's value was measured by its resistance to metal and motion. To accommodate mechanical harvesting, fields expanded into massive, unending rows designed for total uniformity. Growers rely on fertigation, a highly precise system that feeds exact, constantly shifting percentages of water, nitrogen, potassium, and calcium directly to the root systems through drip lines. A single failure in this chemical balance triggers physiological breakdown. A minor deficiency in calcium, or a drop in soil moisture, causes blossom end rot, destroying the fruit from the inside out. If water is absorbed too quickly after a dry spell, rapid cell enlargement causes the tomato skin to violently split open with deep transverse cracks. Even a brief exposure to temperatures below 60 degrees during the seedling stage causes cat-facing, severe, permanent physical scarring at the blossom end. The modern growing operation operates as a tightly controlled chemical factory. A single environmental miscalculation across thousands of acres renders the entire yield commercially worthless. If a crop survives the field, the mechanical harvest is deliberately triggered before the tomatoes actually turn red. They are picked at a highly specific biological phase known as mature green. Inside a mature green tomato, fully formed seeds slip away from a knife uncut, and a protective jelly completely fills the inner cavities, or locules. Immediately after machinery lifts them from the dirt, green tomatoes are washed, sized, and sorted along a strict visual grading scale that determines exactly where they will go. This chart illustrates the industry color classification. Fruits graded as green, breakers, or turning are highly durable and designated for long-distance transport. Tomatoes further down the line, pink, light red, or fully red, are too soft for long trips, routed instead to local markets or processing plants. A tomato's exact shade at harvest dictates which supply chain route it follows, whether it's sold fresh, canned, or processed. Those long-distance green tomatoes are packed loose into strong, well-ventilated cartons, carrying exactly 11 kilograms to prevent the bottom layers from suffering compression bruising. This thermal graph highlights the temperature tightrope of the cold chain. Transport trucks must maintain the ambient air between exactly 12 and 15 degrees Celsius. If the temperature inside the trailer drops below 50 degrees Fahrenheit, even briefly, it permanently destroys the fruit's ability to develop its flavor and color. Once the trucks arrive near their final destination, the mature green tomatoes are placed inside massive sealed metal chambers. Sprayed with ethylene gas, the biological ripening process is artificially triggered, forcing a bright blush of red to rapidly spread across the skin. The bright red color on a supermarket tomato is a highly scheduled chemically induced event, perfectly timed to match its arrival on the shelf. Jack Hanna's resilient VF-145 tomato and the mechanical harvester were an immediate industrial triumph, saving the Californian market from total collapse. This area chart shows the staggering speed of that agricultural revolution. In just 3 years, the adoption of mechanically harvestable tomatoes rocketed from 7% of California's acreage to 85%, eventually reaching near total saturation. But the required machinery and specialized hybrid seeds carried an immense financial barrier. Farmers had to purchase massive tracts of land just to scale their operations enough to turn a profit. This infographic maps the resulting socioeconomic fallout. Within 5 years of the harvester's release, nearly 4,500 of the state's 5,000 tomato growers went out of business, while an estimated 32,000 farm workers lost their jobs. The price of a perfectly efficient, machine-ready crop was the systematic destruction of the traditional small farmer and the manual laborer. We interact with this highly engineered product every day, casually placing it into our shopping carts, completely unaware of the history behind its uniform shape. The journey of a commercial tomato requires a brutal gauntlet of complex genetic tweaking, precise chemical fertigation, heavy mechanical harvesting, and synthetic ripening. The modern commercial tomato is a biological survivor, a fruit physically modified to withstand an industrial process that consolidated the American farm.